Good morning, viewers. I am Saraswathi, working as an assistant professor in CST department in SNS College of Engineering, Coimbatore. Today we are going to see about first order logic. First order logic, it does not only assume the world contains fact like proportional logic, but it's also assume the following things in the world: an object, A and B, the people, numbers, colors, words, theory, square, bits, compass. The relationship is it can be an inner relation such as red, round, is adjacent, or in number of any relations such as sister of, brother of, has color comes between. The function is a father of, best friend, third innings of. As a natural language, first order logic has two main parts, syntax and semantics. First order logic is another way of knowledge representation in artificial intelligence. It is an extension of the propositional logic. The FOL is sufficiently expressive to represent the natural language statement in a concise way. It's also known as a predicate logic or first order predicate logic. It's a powerful language that develops information about the object in more easy way, and it can also express the relationship between these two objects. It contains the following things: object, relations, and functions. Basic elements of first order logic. The constant can be written as a numbers or alphabet or names or any object. Variables is a alphabet letters. Predicate is a brother of, father of, like that. Function. To find the value of that function is called as a function. Square root, left leg of, that is. Connectives. By using a logical connectives and or not negation, implication implies bidirectional implication. Equality. Quantifier. For all X and there exists quantifier, universal and existential quantifier. Atomic sentences. The atomic sentences are the most basic sentences of first order logic. The sentences can be represented by using a predicate symbol followed by a parenthesis. It's a sequence of terms. We can represent atomic sentences as a predicate of term 1, term 2, etc. up to term n. This is a representation of atomic sentences. For example, Ravi and Ajay are brother. Here, the function is a brothers of Ravi, Ajay. These are the variables, Ravi and Ajay. Brother is a predicate. Next, Chinky is a cat. Cat is a predicate. A variable is a Chinky. Another is a complex sentences. The complex sentences are made by combining atomic sentences by using logical connectivities. It can be divided into two parts, subject and then predicate. Subject is the main part of the statement. Predicate can be defined as a relation which bind two atomic sentences together in a given single statement. First order logic. For example, if x is an integer, it consists of two parts. First part is a subject, another part is a predicate. The subject is a x, predicate is a integer, x is a integer of x. Quantifier. There are two different type of quantifiers are there. The quantifier is a language element which generate quantification, and quantification specify the quantity of specimen in the universe of discourser. These are the simple that permit to determine or identify the range and the scope of that variable in the logical expression. Quantifier are used to identify the range and scope of the variable. There are two type of quantifier, universal quantifier, existential quantifier. Universal can be written as a for all, everyone, everything. Existential for some, at least one. Universal quantifier. It's a symbol of logical representation, which specify that the statement within its range is true for everything. Each and every variable specify the statement is true or every instance of particular thing. It can be represented by a symbol for all, which resembles an inverted A. If x is a variable, then for all x can be written as read as for all x, for each x, for every x. This is an example. For example, all the man drinks coffee. It can be written as x1, x2, etc. up to xn. These are the variable drinks coffee. Then universal of disclosure. And for all x, man of x goes to drink or x comma coffee. These are all x where x is a man who drinks coffee. Existential quantifier. These are the type of quantifier which express that the statement within the scope is true for at least one of the instances for something. The given statement is true for at least one of the instances. It is denoted by the logical operator there exists, which resembles as inverted E. It is when it is used with a predicate variable, then it is called as a existential quantifier. For example, if x is a variable, then existential quantifier will be for all x or there exists x or there exists y. And it will be read as there exists a x for some x for at least one x. These are examples of a existential quantifier. Example, some boys are intelligent. The sentence can be written as we can apply the statement x intelligent for x1, x2, etc. up to xn. There exists x, boys of x, intersection, intelligent of x. It will be read as there is some x where x is a boy who is intelligent. Existential quantifier. There are properties of a quantifier. There are some properties are there. For example, for all x, for all y is similar to for all y, for all x. In existential, there exists x, there exists y is similar to there exists y and there exists x. Both the universal variables and existential variables are common associative property. But in both universal and existential cannot be reversed for them. Some of the examples of a quantifier. All the birds are flying. In this question, the predicate is fly. Play of bird. Play of bird. We can write it as play of bird. The sentence can be written as all birds. So we can include for all x. Bird of x, which imply play of x. Bird of x, which imply play of x. Second one example is every man respect his parents. The predicate is respect. Respect here, the two variables are there. X is a man and y is a parent. The respect of x comma y. X is a man, y is a parent. There is every man we will use a for all x. So it can be represented as for all x, man of x, which implies respect of x, comma, parent. X, comma, y, where y is a parent of x. Third example is some boys are playing cricket. The predicate is play. Here two variables are there, boys and cricket. Our play of x, comma, y, where x is a boy, y is a game, that is cricket. Where some boys, so we can represent as there exists x. It will be represented as there exists x, boys of x, which imply place of x, comma, y, where y is a cricket. Not all the students like both mathematics and science. Not all the. That is negation. Predicate is a likes of x comma y, where x is a student and y is a subject. For all the student, so we will use a for all x. Since not all the student, so we have to use the negation symbol. For negation for all x of x is a student, student of x. For all the student of x, which imply likes of x comma mathematics and likes of x comma science. X comma x is a mathematics. The student likes mathematics. And next one is a like X comma science. A likes is a student likes science. Okay, that's all. Thank you.